So imagine you've built your app, you've built your database, and you put them both in a container, and when you try to connect them, you get the famous connection refused error message. So you try localhost, but it doesn't work. You try the container's IP address, it works today but fails tomorrow. You try mapping ports, but suddenly your host machine is a mess of open ports that you don't even recognize. And so Docker networking is one of the main reasons developers get frustrated with containers. It feels like a black box of virtual bridges, NAT rules, and IP tables, but in 2026 it does not have to be that way. So think of your host machine, whether it's a laptop or a server, as a main house at an address, and think of the container as the tiny guest house in the backyard of that main house. Now, if someone from the street, in other words from the internet, wants to talk to the guest house, they have to knock on the main house's door first, and this is port mapping. Now, if the guest house wants to talk to another guest house in the same backyard, they don't go out to the street, but they use the backyard bridge. This was probably a stupid analogy, but anyway. The confusion happens because every container thinks it's living in its own private universe. It has its own local host. So when container A says talk to localhost, it's not talking to its neighbor, it's actually talking to itself. So to fix this, Docker creates drivers. Now let's look at the most common ones. So first we've got the default bridge. So when you run Docker run without any flags, you are put on the default bridge. Now here's the problem. In the default bridge, containers can only talk to each other via IP addresses. But container IPs, as we all know, or maybe some of you don't, but anyway, container IPs are like temporary phone numbers. They change every time you restart the container. So here's a tip for you. Never use the default bridge for production. Why? Because it doesn't support the automatic service discovery. So you want your app to talk to DB or database, but not to the container's IP address. And to get that, you need a user-defined bridge. Now, when you create your own network, Docker turns on a secret DNS. So now container A can find the database, and Docker will know exactly which IP to route that to. Now, sometimes you want to skip the backyard analogy and just put the container inside the main house, and this is called host networking. For instance, you can use network host when performance is needed. Maybe you're running a high-speed AI inference or a network monitor, and here there is no isolation. The container shares the host's IP and ports directly. Now this is fast, but it's risky because of port conflicts. On the other side, we've got none. So network none means that the container is a vault, so no internet, no neighbors. So this is used for batch processing high sensitive data where you want to guarantee that nothing can leak in or out. Now let's talk scale. So what happens when your backyard is full but you want to build guest houses on another property? Well, this is where overlay networks come in. This is the heart of Docker Swarm and Kubernetes. So an overlay network creates a virtual tunnel between different physical servers. To the containers, it feels like they are on the same local bridge, but in reality, the data is flown across the data center. Also, there is Macvlan, and this is for the old school networks. Macvlan gives your container its own physical MAC address. So to your router, the container looks like a real physical laptop plugged into the wall. So you use this when you're dealing with legacy apps that require being on the same subnet as the physical hardware. Now, when things go south, don't just restart the container. Use these three tools. First, we've got Docker Network Inspect. So this is your X-ray machine, as it shows you every container on the network and their IP addresses. The next command is docker exec, which is used to test the network connectivity between two Docker containers. So it essentially tells Docker to jump inside one container and try to send a signal to another container and see if they can talk to each other. Now the third tool is the port mapping check. So you need to verify that your -p flag correctly maps the host port to the specific internal port where your app is listening, otherwise the connection will fail. Now let's recap. So for single machine and multiple containers, you use user-defined bridge. You want performance, you use host. You want multiple servers, you use overlay. And you want legacy hardware, you use Macvlan. So in essence, Docker networking isn't confusing because it's hard, but it's confusing because there are so many ways to do it. Just stick to the user-defined bridge for 90% of the time, and you probably will never see the connection refused error message again. Now that's it for today's video. I hope everything was clear. If you got any questions, drop them in the comments below. Don't forget to hit that like and subscribe button. If you want to learn more about AI, IT, and cloud, please check the link in the description below, and I will see you in the next video.